All right, this video is going to grade bonding 3, and then we will move on to learning about polarity. So this worksheet's worth 55 points. Please make sure you're grading in red, and you're going to write your score out of 55 and show it to me the next time I see you, please. So here we go. CL2, remember, it's 2 points for the structure, 1 point for drawing the shape. So CL is single bonded, 3 lone pairs on each CL. It's linear. Saying that it's linear is worth 1 point. Here I have N2, it's a triple bond between the two ends, lone pair on each end. 2 points for the structure, 1 point for drawing it linear because the shape is linear. Next one, H2S has 2 lone pairs, 2 bonded pairs, just like water, right? So you have to draw, right, the structure correctly. That's 2 points. Drawing it to shape, 1 point right here. You have to show that it's bent because the name is bent. Here, trigonal pyramidal, you have to draw it like a pyramid. It doesn't matter if you have the wedges or just lines, but it has to look like a pyramid. AS with 1 lone pair at the top. So 2 points for the structure being correct, 1 point for drawing it pyramidal, and the shape is trigonal pyramidal. Next one, this one, you have 4 things attached. It's okay if you drew it, right, like a plus sign, but all your CLs should have 3 dots and the H should have no dots. This is tetrahedral when 4 things are attached. So remember, 2 points for the structure, 1 point for drawing it tetrahedral, or you could keep it as a plus sign. C2H2 is straight across, linear, right? Because, or no lone pairs on the C's. So 2 points for having the triple bonded C's and then single bonded to the H's, and it's straight across. SIS2 has 2 lone pairs. This looks just like CO2. So S has 2 lone pairs here. SI is double bonded here and here, lone pairs on the S's. 2 points for the structure being correct, 1 point for drawing it straight across because it's linear. The next one is NO3 1-, 1 point for brackets in charge, 2 points for having an N double bonded to one O, single bonded to the other O's. When it's double bonded, 2 lone pairs, single bonded, 3 lone pairs. 1 point for drawing it like a triangle spread out, right? And it's trigonal planar for the name. NH41+, you could have drawn this one as a plus sign. N is single bonded to 4 H's. 1 point for bracket in charge. It's tetrahedral. Next one is S3. You only had to draw 1 structure. It doesn't matter if the double bond's over here or on the left. But one of the S's is single bonded, the other one's double bonded, and there's a lone pair on the S. Remember, we care about the shape around the central atom. It is bent. BCl3 is one of our exceptions. Careful with the B's. You're going to have Cl attached 3 times, and then you're going to have 3 lone pairs. Spread them out as much as possible, trigonal planar. PCl5, SCl6. It doesn't really matter if you drew like the wedges out here or here. It's just 2 of them have to be 3-dimensional. This is trigonal bipyramidal. This one is octahedral, so it's 2 points for each structure, 1 point for drawing them to shape. And then here, last one, CO3 2-, brackets in charge, right? Double bonded to an O, single bonded to O's, right? And then here, has to spread out 3 things equally. That's trigonal planar. So remember, have your score out of 55 points. Okay, now what we're going to do is move on to notes that deal with polarity. So remember, so now we're on page 11 of the notes. It's going to help if you have a calculator and also if you have a different colored pen so that you can show the polar bonds. Okay, so here we go. Nonpolar is when electrons are equally distributed. We saw this on the first day of notes, right? But you can see that the electrons are equally distributed around this molecule. Here, polar is when there's an unequal distribution. In other words, one side of the atom is pulling on the electrons more than another. So how do I know, right, if the molecule is nonpolar covalent, polar covalent, or ionic? If it's nonpolar covalent, the electronegativity difference is between 0 to 0.39, polar covalent 0.40 to 1.99, and then ionic is greater than or equal to 2.0. So we already know that, we've practiced that, but now it's coming back. We've been looking at bonds. Are the bonds non-polar covalent or polar covalent? All right, now what we're going to do is look at if the molecule is polar instead of just the bonds. So in order for a molecule to be polar, it requires two things. The first one, the molecule must contain at least one polar bond. In other words, is there at least one dipole? How do we figure that out? We look at differences in electronegativity. The second condition is symmetry cannot cancel the polarity. So what I've done is I've learned to teach this by asking two questions. So the first question that we're going to ask, is there at least one polar bond? In other words, right, do we have at least one dipole? So we're going to ask ourselves, is there at least one dipole, right? And then I have to look at, do these dipoles cancel? So based on us answering these questions, we're going to figure out if the molecule is polar or nonpolar. So the first condition, is there at least one polar bond? Is there at least one dipole? If I say no, I don't meet the first criteria, and the molecule is automatically nonpolar. If I do have a polar bond, and I say yes, right? But the dipoles do cancel, do we agree that these are the same answers? Yes, yes. So because they're not opposites, that means that it's nonpolar and the molecules are spread out equally on the molecule. But if I have a dipole and they don't cancel, do you see how these are opposite answers? Yes, no. Opposite answers, opposite extremes, that means that it is polar. Okay? So the only time it's polar is going to be when you have a dipole, but the dipoles do not cancel. So how do I figure out if a molecule is polar? The first thing is that they have to be drawn to shape. So what I have done, right, to make the notes easier is I've drawn these to shape, which is important. We know now how to draw structures. We learned that on day 1, day 2. Then we learned, right, that we have to draw them to shape. So here, two things attached, the best way to draw that would be linear. So the geometry of this is linear. So now what I have to do is subtract the electronegativities to figure out the bond type. So if I subtract two ends, because I have two ends here, I have 0. That is non-polar covalent, which means I don't draw a dipole. So in order for me to figure out molecule type, question 1 is there at least one dipole? Right? Is there at least one dipole? Well, I had no dipoles. The answer is no. So it's automatically a non-polar molecule. We're going to do intermolecular forces the next day, so don't worry about this column. Let's look at HCl. When I attach two things straight across, that's linear, right? So now I'm going to look at if there are any dipoles. So in order to figure that out, I have to subtract these two. 2.20 minus 3.16. I put that in my calculator, take the absolute value, 0.96. 0.96 is between 0.40 and 1.99, so that is polar covalent. And I'm going to draw the arrow so that it points towards the more electronegative atom, which is Cl. So the dipole points towards the Cl. So Cl is going to be represented. I'm actually going to do it in a highlighter so it's easier to see. Okay, so I'm going to point the dipole towards the Cl. So there's my dipole. So now I'm going to ask myself the two questions. So question 1, so these are the two questions to figure out if it's polar or not. Is there at least one dipole? Yes. The second question is, do the dipoles cancel? Okay, so how would this cancel? This would only cancel if I had a dipole pulling this way towards the left. So think of it like this, right? All the electrons are being pulled towards Cl. A molecule will be polar, right, if there's at least one dipole and there's nothing to cancel it. So now, what would this molecule look like? If I were to look at this molecule and look at the electrons, really what I'm going to see, and you don't need to draw this on your homework, but what I'm going to see is that all the electrons are going to be over here and not that much over here, because what this dipole means is that the electrons are being pulled to the right. So in order for this to cancel, I would need something pulling this way, opposite, okay, or something pushing this way, and I don't have that. So do they cancel? No. So because I said yes, no, the molecule is polar. All right. If I were to look at what the electrons look like here, right, what we said is that it wasn't polar, it's nonpolar. So what those electrons would look like around this would be that they're evenly distributed. No side is pulling the electrons more. And so that is the biggest difference. Are the electrons equally around both atoms, or is one side pulling them more? Non-polar molecule, a polar molecule. Once again, you don't have to draw what I shaded in gray, but that was just to show you what the electrons are doing within the molecule. So now we move on to page 12. So we are looking now at CO2. CO2, right? The geometry, these are already drawn to shape, straight across. This is linear. I want to figure out the bond type, so I'm going to subtract these. 2.55 minus 3.44, absolute value is 0.89. This falls between 0.40 and 1.99, so this is polar covalent, which means I have to draw a dipole, and it's going to point towards the more electronegative one, which is going to point towards the O. So C to O, 0.1 here this way, and 0.1 here this way. So now, once again, in order for me to figure out the molecule type, it's either going to be polar or nonpolar. I have to ask myself two questions. Question one, does it have at least one dipole? Well, let's see. Does it have one dipole? Yes, it has two. All I need is one. Two, do the dipoles cancel? Okay, if I have something pulling this way to the left and something pulling to the right, and they're equally pulling, they're going to cancel. So because it cancels, I answered yes, yes. And according to my notes, we said that if we answer yes, yes, the same answer, right, it's nonpolar. So this is nonpolar. What does this mean? Once again, one side is pulling more and the other side is pulling, right? And so what's going to happen is it's going to equally spread out, and it shows that the molecule has the electrons all over equally distributed, okay? Once again, you don't have to show what I just shaded in. Now, the next one, CCl4. When we talked about Vesper, I said it's okay if you draw it like a plus sign. You don't have to draw it three-dimensional, because I feel like it's easier to see in this representation, okay? So what is the shape of this? Four things attached, no lone pairs. We learned that that is tetrahedral. So now I want to figure out the polar, if it has a dipole or not, right? So I take 2.55 minus 3.16. When I subtract those two, take the absolute value, I get 0.61. That's definitely between 0.40 and 1.99, so that is polar covalent. And I am going to point it towards the more electronegative element, which is 3.16. So it's going to point towards the Cl. So how many do I have? 1, 2, 3, 4. Okay? So now I have to figure out if the molecule is polar or nonpolar. Question 1. Is there at least one dipole? Yes, I have 4. 2. Do the dipoles cancel? Okay, let's see. This one cancels with this one. And then this one cancels with this one. So, do they cancel? Yes. Because I said yes and yes, they're not opposites, so it is non-polar. Next one. This one is drawn to shape. Remember, all of these are drawn to shape. If you don't draw them to shape, you're going to get the wrong answer. So remember, we were drawing these little balloons around the lone pairs, and then that reinforces that this has to be pushed in. When there's 3 things attached to lone pair, this is trigonal pyramidal. So now I subtract these 2, and when I subtract these 2 and I look at the absolute value, I get 0.84. So it's definitely polar covalent. And then I go ahead and point it towards the more electronegative atom, which is nitrogen. So it's going to point this way, pointing towards this way, pointing towards this way. Okay, so now I'm going to look at, is the molecule polar or nonpolar? So question 1, right? Is there at least one dipole? Yes, there is. 2, do the dipoles cancel? All right, if I have something pushing up this way, so the electrons are being pulled up this way, pulled up this way, pulled up this way, the only way they would cancel is if something was pulling down. Because there's nothing pulling down, they do not cancel. Because I said 2 opposite answers, yes, no, the molecule is polar. So now, what does this mean, right? It means that if I were to look at this molecule, the electrons are hanging out up here and not towards the H, okay? This one is the hardest for students to know. So I want you to TQ this. Every year, so many students miss this one. And what I'm going to tell you, right, is that this shape here is drawn to shape trigonal planar. So this is trigonal planar. If I take 2.04 minus 3.98 and I subtract those, I get 1.94. That's highly polar covalent. So now I'm going to draw my dipoles pointing towards F. So 1 here, 1 here, 1 here. Because these are equal angular, they're going to cancel. This one cancels this one and this one because they're all pulling with the same amount of force, equal angular. All right? So, number 1, does it have at least one dipole? Yes. 2, do the dipoles cancel? Yes, they do. So it is non-polar. Last one here. Remember I said no for the rest of your life that water is bent? This is water, it's bent. It may help to put the lone pairs, right? So then now, right, I subtract these 2 to figure out if it is polar or nonpolar covalent. 1.24, definitely polar covalent. I'm going to point towards the more electronegative atom. So here is oxygen, right? And that's going to point towards the O. So now, question number 1. Do the dipoles cancel? Question 1, is there a dipole? Yes. 2, do the dipoles cancel? Let's see. I have something pushing up towards the O, pushing up towards the O. I would need something pulling down in order for it to cancel. So the answer is no. Because I said extreme opposites, yes, no, it is polar. Now, what does that mean? It means that the electrons are hanging out over here, being pulled more by this O, not so much by this H. Okay? So let's figure out, right? Because we're always trying to look for patterns. What type of molecules are polar? It's going to be polar, right? When we have one dipole and it's linear. So that's one option of when it's going to be polar. The other option is when we have lone pairs, polar, polar. All right? Now, I want us to add another example. What if I have something like this one here, but I change this to H, C, Cl, 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 right? So right now, I'm going to tell you that we already know that CCl is polar. So it's going to point towards the Cl, right? But is there a dipole for C to H? When I subtract those two, I get 0.35. So there's no dipole up here. So it's going to be, this one is a polar molecule. And the reason why is because these don't cancel. This one cancels with this one, but this one doesn't, right? So you're going to have a polar molecule when there's lone pairs and you have at least the first criteria met, and if it's linear and it has a dipole because there's nothing to counter it, all right? But when they're equal angular and the same atoms, equal angular, same atoms, equal angular, same atoms, they're always nonpolar. So now, looking at the homework, your homework is to do bonding 4. But in bonding 4, you're only going to do the first 1, 2, 3, 4, 5, 6, 7 columns. Save this for the next day. So this one, skip for this homework. You don't have to do this column because I haven't taught you intermolecular force. It is front and back, and we will grade this in class, so you don't have to upload this unless I'm not seeing you the next day. Okay? I would look at page, I want to say it's page 4 of the notes. Let me just double check here. I would look at this page because this is a nice rubric, right? Do you have the right structure? Do you have resonance? Right? That continues with resonance. Did you draw it to shape? Is it a polyatomic ion? Did you draw your dipoles? So this is kind of a good way to kind of getting you used to how I'm going to grade you on your structures when we look at the review, the lab, the test. This is exactly how I'm going to grade you, so get used to doing that, okay? Remember, if you have any questions, please email me.